In change of order of integration, let us see a problem. Evaluate integrating 0 to 1, integrating root y to 2 minus y, xy dx dy by change the order of integration. So, given double integration is integrating 0 to 1, integrating 0 to y to 2 minus y, this is root y, xy dx dy. We are all know. So these limits are in y, functions of y. If the limits are functions of y, then these are limits of x limits. If these limits are x limits, then these limits are y limits. Now y limits are 0 to 1 xy. So variable x limits are variable limits, integrating with respect to x is first, and y limits are constant, integrating with respect to y is last. So after changing the order of integration, we have to change the order of integration. That means we have changed this order of integration. Means integrating with respect to y we have to perform, and with respect to x next. So how to change the order of integration? How to change the limits? So to change the limits, we first consider the limits. Given limits. Given limits are y equal to 0, y equal to 1, x is equal to root y, x is equal to 2 minus y. So these are the two curves. Squaring on both sides, we get x square is equal to y. So this is one curve. And if you simplify, x plus y equal to 2. This is straight line. Draw the diagram first. The diagram is like this. So this is a parabola. This parabola is okay on y-axis. The name of this parabola is x square equal to y. And this is the straight line. This straight line is this. This straight line touches here, right? So this straight line is x plus y equal to 2. Okay. Now this is the region, and in the given limits y equal to 0. Y equal to 0 is this x-axis. So y equal to 0 this line, and this is curve, and this is the curve. The complete region is this. So this is our region. So in this region we change the limits. How to change the limits? So here these two curves are intersecting at here. So after solving these two curves, x plus y equal to 2 and x square equal to y, we get intersecting point. This is intersecting point is 1 comma 1. After solving these two. So this is the origin we know, and this is the point. This point is 2 comma 0, right? So this is our region, and this split this region into two parts because of here three corners are there. So split like this. So this is O, and this is A, and this is B, and it is, you consider it is C, capital C. So this split this region into two parts. Now our region is OAC is one region and ABC is another region. So change the limits. To change the limits, we separate the region into two parts. In the region OAC region is this. So we are changing y limits as variable limits because in the given problem y limits are constants. So y limits are constant, therefore draw a strip parallel to y axis in the first region. So this is our strip. This strip is PQ. This is PQ. So this strip touches at P and Q. At P, y value is 0. You know, x axis, y is 0. At Q, this curve at q, this strip touches this curve x is equal to y. So therefore y equal to x square. So we obtained y limits, but in the given problem y limits are constant, but after changing the order of integration y limits are 0 to x square. Now what about x limits in this region? So if the y limits are functions of x and x limits must be 0. So in this region x limits. So in this region x starts, the region start here and ending here at origin x is 0 and x is 1. X is equal to 1. So this is one part, and the another part of the region is this ABC. ABC. This is in the region ABC. At to draw a strip again. Draw a strip parallel to y axis because the y limits are constant in the given problem. This is strip. So I am writing this is RS. RS. At R, at I am writing at S. At S, y is 0 because it is x axis, and this is at Q. And at R, this curve touches R. R is straight line x plus y equal to 2. From this y equal to 2 minus x. So we obtain uh, y limits and x limits are. So in this region x limits are x starts here and ends it here. X limits it here at this point it is 1 and it is 2. 1 comma. So our problem is integrating 0 to 1, integrating root y to 2 minus y, xy dx dy. This is our given problem, but after changing the order of integration, the region is divided into two parts, and you split partition this integration to two parts. So first part is OAC. In OAC, y limits are y0 to x square and x limits are constant. So x limits are constant and y limits are 0 to x square, and problem is xy. Integrating with respect to y first, and x limits are constant, integrating with respect to x next. And another part is this part ABC. In ABC, x limits are 1 to 2 and y limits are 0 to 2 minus x. So xy, integrating with respect to y first and with respect to x next. So by integrating we get the solution. So I am doing integrating x is equal to 0 to 1. So we are integrating with respect to y first. So x is constant, y square by 2, limits 0 to x square dx, plus integrating x is equal to 1 to 2, x y square by 2, limits are 0 to 2 minus x dx. So after substituting the limits, we get integrating 0 to 1, 1 by 2, x power 5 dx. So integrating 1 to 2, 1 by 2x into 2 minus x whole square dx. So then 1 by 2, integrating 0 to 1, x power 5 dx, plus integrating 1 to 2. So after simplifying this, x cube, so 1 by 2 is here, minus 4x square plus 4x into dx, right? So now integrating, this is x power 6 by 6, limits 0 to 1. So here also x power 4 by 4, 4 into x cube by 3, plus 4 into x square by 2, limits 0 to 1. After substituting all the limits, we get the solution is this.